Hello there, Skeptic Squids. How are you doing today? In this video, we're going to be doing some surgery on our very expensive equipment. So what we'll need to do is just do some maintenance on this here, which is what we call the preparation chamber, and we'll be venting the ultra vacuum, going through the procedures on how to do it properly so that you don't blow the system up or implode the system, destroy things, which would cost a lot of money. And we'll also be doing just a small little transfer of a sample right there into the preparation chamber. I'll do a separate video on how to move samples around. It's actually quite interesting and rather fascinating engineering. But that's what we're going to do for today. I hope you enjoy. Now what we'll be doing first is moving a sample from the analysis chamber into the preparation chamber. To do that, see, there's the preparation chamber, there's the analysis chamber, and we can turn on the light and you can see there is something there. Now we're going to be moving that into that chamber right there. Before we can do that, we need to bring these two chambers into vacuum contact. Now, conveniently enough, we have our little vacuum gauges there. The top one is the analysis. That's at 3.37 times 10 to the negative 10 millibar, and our preparation is at 4.5 negative 10. That's close enough for what we'll be doing, so we can then make sure that everything else is closed. As it's closed, it's not in vacuum contact with where we load the samples. Everything else is closed due to maintenance on a different element there. So I'll be confident enough to open up this valve. There you go. We open it up and then we can immediately see that those two start to change as they'll be migrating toward each other. Obviously it's not catastrophic because they're at the same order of magnitude. Now comes the interesting part. We'll be moving a transfer arm with a little hand on it. I'll call it a hand for now, into this little device here. Before we can do that, we will need to move this so it actually faces our transfer arm. Now that we're moving the manipulator, we'll see that we have a little screw there. It's turning ever so slightly. Make sure that nothing is in the way that can cause a crash. And we'll slowly see the manipulator moving into the position that we want it to be at. So I'll come back when that's moved into position. Now while we're waiting for that magnificent arm to move into position, we can come here to make sure that our pathway is clear for our manipulator right here, or transfer arm, sorry. If we look through there, we can see that we have an obstruction there from someone who previously working on the chamber. So if we move this arm, we will damage that, which is obviously not what you want. So we can come here, we can see where that little arrow is, and we'll move that up. So as you can see, while we're moving it up, it's going up slowly but surely. It'll be nice if we could just have a motorized arm on this. So that goes up. When we take it to about close to 200, that'll be nice and out of the way so we can move the transfer arm to pick up the sample. There we go. We've moved it to 200, and I can just illustrate by moving the transfer arm. There we go. See, now it can pass through there without hitting any obstruction, which is convenient, since while I was doing that, this thing the manipulator moved into the proper position. So I can come to this side just to make sure. There we go, our sample. Do you see the little tab there? That's where we're going to be picking it up. Now you can see the sample is facing that direction. Now, of course, you can't reach that from here. So what I'll do is move it a bit forward. There's a little mark there. Now obviously I've made sure that there's no obstructions, and I've made sure that it's open there, so I don't have any problems moving this right there. Now comes the tricky part, actually picking up the sample. So I'm just going to set up the camera so you can see how I do this. Now that I have the camera set up, I can look and stretch and move the transfer arm towards the sample. There you can see it's right there. I'll align it with that flat edge along the flat edge of that tab on the sample holder, and I'll gently come in and bump it because the Z is not properly set up. Let me set up that quickly. Now that the Z has been organized, we need to move it closer again, and you can see it still doesn't fit properly. That's because the X is a bit off center, so we can move that by hand. First, not having it touching, we can move it by hand. We can bring it closer again. And there we go, we have contact. Now we rotate this to lock that sample in place very gently, otherwise you will bend the tab. Now it's locked, and I'll gently move it out of that holder. There we go. Now that sample is free floating, and if I could just move the tripod out of the way, I'm going to put the camera right here so you'll see how I'm going to put this sample in the holder there. There we go. There we go. Let's move it. Now you would have seen I moved the sample out of the way. That's because what we need to do now is bring that holder down. But before I do that, I'm going to make sure, because I know that transfer arm is out of the way, I can't see it there, I know I can close this, which I'll do now because this is a critical part to separate these chambers. Locked in place, and that is now closed properly. So you can come back to this side and make you drunk while moving around. We can move that down so we can place that sample in the holder, and again we'll make sure that we are not in the way, otherwise we will damage things, and we'll bring it down. So I'm going to place the tripod down here so you can see it coming into place. Might stop the video just to get a good position. Okay, from this angle you will be seeing how I move down that manipulator, and place that sample into a holder. It's a bit of a finicky process, but it's not that bad. Okay, so we're more or less at the right Z. Now we just need to rotate it. This is also done manually, so it can be done nice and quickly. Well, quickly is relative when you're dealing with these things. And now comes the moment of truth, if I can remember all my values correctly. This should just slide in nice and easily. Oh, fuck yeah, there we go. Just like that. Now, here comes the thing that most people, well, I've made this mistake before. If you rotate this in the wrong direction, you actually bend the tab. The reason that happens is because the tab is quite soft, it's thin, and you have a really good mechanical advantage when you're dealing with the transfer arm. So what I like to do is I use my pinky to apply pressure in the direction I think is the correct direction. If I feel any resistance, I stop immediately. So I'm gonna on purpose move it the wrong way, and there we go. Just like that, I feel the resistance in my pinky finger. So I'm gonna move it in the other direction without moving it away, like that. Just like that. So right now I'm facing it down the sample, so I can't see if the left and right is as good as you will see it. So let me come on that side. Oh, that looks good. It could go in a bit more, but it's not gonna fall off. In fact, I'm gonna be safe rather than sorry and push it ever so slightly in, so it makes sure contact with those stopping washers you see. So I'm gonna come in, on purpose turn it sideways, and then I'll just gently apply pressure. There we go, until I feel the resistance, and then I'll move back. And now I'm going to move back to transfer arm until I hear that noise. That means it's the very end. And there we go. Now the sample is nice and safe outside of the analysis chamber. And the next part is going to be how to vent the preparation chamber. Now we will need to actually prepare the preparation chamber to be vented. So first off, the most important part is to actually switch off the preparation vacuum gauge. And the reason for this is because it runs using a filament, and you all know from what happens when you expose a light bulb to air, it burns out. So we are going to shut that off. There we go. Now the second most important part, well, maybe this was the most important part. It doesn't really matter. They're equally important because in either way you're destroying things that's quite expensive. So I've already established that this is closed. I'll come to the other side and show you. It's closed, and right there this valve is closed, and there's no other valves in this chamber. So next up, we're going to cut off. This is the scroll pump, which is for a raw vacuum and keeping a backing pressure, or a lack of backing pressure. So we're going to close this. There we go. That's closed. We again make sure that's off. Another thing we have to make sure is that our titanium sublimation pump is off. That light's not on, nor is it blinking, so the TSP is off for the preparation chamber. So now you can see there that our turbo is running at 1000 Hertz, and that is a pressure of 8.84. I think it's also millibar. So what we can do is we can just turn it off. There we go. And then that would turn off the scroll pump. So now we should enable venting on the system. So we have to look for it using these little stupid controls, which is always annoying. So I think I'm gonna stop. Wait, vent time. Nope, it's not. I don't like these things. I would like to just connect them onto a computer. There we go. Now that I'm on the enable vent function, you just quickly press these two buttons, and that arrow will pop on, and then you enable vent like that, and that should start enabling a venting process. Now another thing we can just quickly check is our little bleeder valve here. There we go. We know there's pressure there. That's actually full of dry nitrogen. So what will happen now is if we again go to that setting, which is lots of fun. There we go. So that's the actual speed of the turbo pump, and you'll see it's starting to decrease. And also the pressure is also going to increase. What's going to happen eventually, once it reaches about 500 Hertz, it's going to slowly start opening up a vent, which would blow. There's the turbo pump right here, which is going to feed nitrogen into the back of the pump, and which is going to fill this chamber with nitrogen. And the reason you do that is so that you don't have absorption of air when you open it to the air. Sounds a bit counterintuitive, but if we get dry nitrogen in there first, we have less water and other garbage on the surface of the inside of the vacuum, and it's easier then to get back to a proper vacuum. So we'll continue the video when we start cracking open this bad boy, and we'll look inside. And the thing is vented. So it took about half an hour to an hour. We can let me like this. Yes. Now you can see the turbo pump is now at 0 Hertz, which means it's static, and it's completely vented to atmosphere now. Next part is going to be to actually do the maintenance that we wanted to do. We need to we need to look at this here. This is a thermocouple attachment. We need to check that, to check at the wires that goes to our manipulator is correctly attached and functional, which right now it isn't, so we need to check where the error lies. And then we also will be removing this entire setup here using a little crane, which is that yellow thing you see in the background, so that we can remove some of the debris inside. Debris being a sump holder that fell off and a couple of other things. But that's going to happen with some help from someone else in the lab. So yeah, that's going to be in an hour or so. So I'll see you there. Okay, so now you can see me there. Now we've already so we've opened up the chamber, and now the entire chamber is now at ambient pressure, and we've actually taken off a window right there, we've removed this from the chamber, so now there's a cavity there. We're going to connect it to a new addition that we've acquired. Now, to attach this, we'll be using a bellow system. Let me just remove this and show you how this looks. And there, everything falls on the ground. There we go. So this is going to be attached between those things there. So before I do that, let me just show you how it's going to be done. On this side will be studs going into blind holes, and this side is through holes, which I'll be using these funky nuts like that. And I'll also be showing you how these CF flanges work, because to make it seal for ultra high vacuum, you actually need to put a copper gasket on a what's known as a knife edge. So what will happen, I can actually have before and after examples for you. Here you can see a gasket that already has the edge on it, so this is now going to be recycled. But here is, in these little vacuum packs, you can see the new gasket doesn't have any edge on it or any imprint on it, and there's an old one with an imprint. So when you squeeze down using your nuts, it actually makes the imprint of that knife edge and creates an ultra vacuum tight seal. But first off, I'll install these M6 nuts. Also, I'm using gloves just to limit the amount of grease I get on any surface that's going to go into the ultra vacuum. Now with these, it's just okay. I see that these are going to be way too long to be inserted, because I won't be able to come in and slide it in. So I won't be able to do that. So what I'll do instead is I'm going to prep the one side using normal nuts and bolts. Put it in like that with the copper gasket, and hopefully, oh never mind, this one has a loose section. Okay, that's actually perfect. That means I can do it the way I wanted to do it in the first place. But as you can clearly see, these videos are not scripted at all. It will be kind of silly to try and script a video where you have to install things, because you never know what's going to go right and you never know what's going to go wrong. Of course, it's not that you can say much while you're doing things like this. Also, these studs are not all of equal length. Doesn't need to be, but it might make some of your OCD go a bit sad. Okay, let's see if I can do this, because oh, there we go. That's why I had difficulty, because the one side is actually sealed. It's the only one side's loose. That explains my confusion. And yeah, I'll need to remove some of the some of them so that I can at least get that section in. Okay, that's going to be good. Now comes the critical part. I have to attach or place this seal gasket in between these edges. So I'll place that down. Here we go. Of course, this needs to be torqued down properly. But before you do that, before you even start doing that, you at least want to make sure all your angles and everything is good and proper. So every one of these studs gets a little washer and a silver plated nut, which should minimize the chances of seizing up. Ah, that looks very ugly. Not sure if you can see, but it sticks out quite a bit. Oh well. Not happy with how that looks, but this is gonna bother me for the rest of the time I'm gonna spend in this lab. Oh well. Yeah. Fortunately, these ugly studs are on the inside, so they're not going to really be in the way of your hand movements. Not that your hands really get here at all, but sometimes they do. At least the opposite side looks good. Okay, so now this entire section is going to be moved until it mates here, but because of that bellow section there, I can move it back and I can insert a new gasket, which fell on the ground, but luckily keep it sealed until the last moment. There we go. Oh, this is quite precarious because if I don't keep it like that, the seal is going to fall out, and once the seal falls out, it'll land on the ground, and when that happens, I have to use a new seal. There we go. I'm going to place this bolt in here, but I'm not going to tighten it because you have to tighten it in a specific pattern. Otherwise, you can squeeze the seal on an angle and not have a proper seal in place. Okay. Okay, there we go. So now I have all these attached. So I'm just applying pressure to seat this properly, and then I'm tightening the bolts with my fingers. The nice thing about these nuts, well, it's not really a nut, it's like a threading plate, is that once you have two bolts in it, you don't have to actually have one side tightened with your fingers. Unlike, for instance, if you were to have like a normal two bolts, because it's just single plate, it can't move anywhere, so it doesn't rotate when you try and rotate to one side. And there we go. So now this entire system is now nice and secure. Secure only, not tightened yet. I'll just check and make sure that everything is seated properly, the copper gaskets. And what I'll do then is tighten these down to a certain torque specification, close this valve, and there we have it. We've just assembled, attached two vacuum systems together, and you also learned a bit about how to mount CF flanges, which are these copper gasket type ultra vacuum flanges. I hope you enjoyed watching these sort of things. And I'm pretty sure, well, not pretty sure, I have a video planned in the future about how to install or how to set up a vacuum system, draw a vacuum, and all those sort of things. But just let me get to a point where you can see my face. And that is it for today's video. I hope you enjoyed this process of doing some open heart surgeries, more or less open heart surgery in a very expensive vacuum equipment. In the future, I'll take you through how to move samples around this system, we're not entirely done. We still have to remove this thing here. Still probably going to be removed, lifted up, but I'll record that as well if you find this interesting, and I'll show you what we do inside there as well. I am working on a debunking video. It's been going very slowly because I have to deal with not only debunking content itself, which is a bit tad difficult, but also on how to write things down and get a format that actually is interesting, and also how to fix the audio. I'm not sure how the audio is in this video because I'm just using my phone's audio microphone as is. I'm pretty sure there's going to be a lot of noise from the lab, but I mean, maybe that's a good thing, then you can know how noisy a lab actually is. I hope you enjoyed this video, and I'm looking forward to see you coming along for the ride next time. Take care.